Mars rovers represent the peak of human innovation, a testament to our relentless pursuit of knowledge about the cosmos. These robotic explorers aren't just machines, they're pioneers on a distant, hostile world, overcoming challenges we couldn't imagine, all to answer profound questions. Could Mars have once supported life? And what does its history tell us about the future of our own planet? When NASA's Curiosity rover landed on Mars in 2012, the event was described as the 7 minutes of terror. Imagine this. A spacecraft hurling through the Martian atmosphere at 13,000 miles per hour must slow to zero and land softly, all autonomously, with no room for error. Mars is 140 million miles away from Earth, and it takes 14 minutes for a signal to travel that distance. By the time NASA engineers received word that the spacecraft had entered the atmosphere, it had already either landed or crashed. No one could intervene. The solution was an unprecedented sequence of engineering feats. A heat shield first protected the rover as it blazed through the atmosphere at temperatures hotter than molten lava. Next came a supersonic parachute, the largest ever deployed in space, slowing the descent dramatically. But Mars' thin atmosphere isn't enough to fully brake a spacecraft. That's when thrusters kicked in, controlling the rover's position as it neared the surface. In the final moments, a sky crane, a hovering platform, lowered Curiosity gently onto Mars using cables before flying away to crash at a safe distance. It was audacious, complex, and seemingly impossible, but it worked. Landing is just the beginning. Mars itself is a hostile world. Dust storms, temperature swings, and rocky terrain make survival and mobility a constant challenge. Dust storms, in particular, are infamous. They can last for months and blanket the planet in darkness, cutting off sunlight. NASA's Opportunity rover, launched in 2003, became a victim of such a storm in 2018. After 15 years of exploring Mars, far beyond its planned 90-day mission, the rover's solar panels were completely obscured, and it could no longer power itself. This tragedy taught NASA valuable lessons. Later rovers like Curiosity and Perseverance were equipped with nuclear-powered generators. These devices convert the heat from radioactive decay into electricity, enabling the rovers to function even when sunlight is scarce. This advancement ensured that missions could continue regardless of Martian weather. But Martian terrain poses its own set of challenges. Beneath the red dust lies a treacherous landscape of rocks, slopes, and soft sand. NASA's Spirit rover, a twin to Opportunity, discovered this in 2009 when it became stuck in a patch of soil. Engineers on Earth worked for months, commanding the rover to pivot its wheels and attempt escape, but nothing worked. Spirit ultimately became immobile, though it continued to function as a stationary science lab for years before its mission ended. To prevent similar issues, modern rovers are equipped with advanced technologies. Take Perseverance, for example. It's not just a robot, it's a thinking machine. Using artificial intelligence, it maps its surroundings in 3D and chooses the safest routes, all without waiting for instructions from Earth. This autonomy allows the rover to travel further and faster than its predecessors, reaching sites that were previously too risky. Communication, or the lack thereof, is another challenge. On Earth, we're accustomed to instant feedback. But on Mars, every command sent to a rover takes 14 minutes to arrive, and every response takes another 14 minutes to return. In that time, the rover must act independently, processing data, executing experiments, and adapting to the unexpected. This autonomy makes the rovers more than tools. They're explorers in their own right. Acting as the eyes and hands of scientists millions of miles away, each rover also carries a suite of scientific instruments that must survive and operate in extreme conditions. For instance, Perseverance houses the MOXIE experiment, which produces oxygen from the Martian atmosphere. It's a small step, but one with enormous implications for future human exploration. If we can scale up this technology, astronauts could generate breathable air and even rocket fuel directly on Mars. Another groundbreaking development is aerial exploration. For the first time, Perseverance is joined by Ingenuity, a small helicopter that has proven powered flight on another planet is possible. Flying above the surface, Ingenuity scouts terrain and identifies areas of scientific interest, giving rovers an unprecedented advantage. The ultimate goal of these missions is bigger than just exploration. Perseverance is collecting rock samples that may one day return to Earth. Scientists believe these samples could contain evidence of ancient microbial life. Meanwhile, every rover mission provides data to prepare for the next big leap, sending humans to Mars. From testing technologies for oxygen production to understanding how to survive the harsh environment, the rovers are laying the foundation for a human presence on the red planet. The story of Mars rovers is one of perseverance, both the humankind and the robotic kind. From Sojourner in 1997, which proved that rovers could traverse alien terrain, to Opportunity, which redefined what mission lifetime means, to today's Perseverance and Ingenuity, these machines are rewriting the boundaries of exploration. They remind us that even in the face of impossible odds, we can achieve the extraordinary. So, the next time you look up at the night sky, remember, we've already got wheels on the ground, paving the way for humanity's next giant leap. Subscribe for more incredible stories like this.